You know, there's an invisible enemy lurking right inside your industrial plant right now. It's silent, it's absolutely relentless, and honestly, it's destroying your energy efficiency from the inside out. Welcome to today's explainer. We're going to expose this silent killer hiding inside your shell and tube heat exchangers. And more importantly, we're going to show you exactly how to defeat it. Trust me, if you rely on efficient heat transfer to keep your production up and running, you literally cannot afford to ignore this.
Okay, let's dive into this. 15 to 30%. Just let that sink in for a second. That right there represents the massive, totally unnecessary increase in electrical consumption caused by scaled systems. See, when minerals build up in your shell and tube heat exchangers, they basically act like a giant thermal roadblock. You end up burning significantly more energy just to get the exact same output you had on day one. And you know what the worst part is? Most plants just accept this as a normal cost of doing business. No way!
But it really doesn't have to be normal. So here's our roadmap for today's explainer. We'll quickly cover the hidden tax of scale, why chemical dosing fails, the AE Flux innovation, changing mineral morphology, and finally, progressive descaling without shutdowns.
All right, let's jump straight into Section 1, the hidden tax of scale. Now, what's really interesting about this slide is how it illustrates the problem. Think of scale like wrapping a thick insulating winter blanket right around your heating elements. Just a tiny 1 to 3 millimeter layer of calcium carbonate inside a shell and tube heat exchanger causes a staggering 10 to 40% drop in heat transfer efficiency. I mean, literally 1 single millimeter cuts your heat transfer by over 10%. To put that into perspective, the thermal conductivity of this scale is roughly 8 times worse than stainless steel. The heat just simply cannot pass through it effectively. And as you might guess, this creates a vicious cascading cycle of failures across your whole facility. Because your heat transfer coefficient, or U value, drops, your system tries to compensate by demanding way more steam. So now you've got longer heating cycles. On top of that, the scale physically narrows the hydraulic paths inside the tubes, which jacks up the friction. That forces your pumps to work significantly harder and draw way more power. Before you know it, you're looking at unplanned production drops, nasty bottlenecks, and utility bills that are absolutely skyrocketing.
So how do we usually fix this? Let's move to Section 2, why chemical dosing fails.
For decades, industries have relied on chemical descaling, right? Things like aggressive acid cleaning, but honestly, it's nothing more than a reactive band-aid. It doesn't actually solve the root cause, it just treats the symptom way after the damage to your efficiency is already done. Plus, it introduces some massive hazards. You've got the constant risk of human error, the danger of overdosing, which can actually induce severe underdeposit corrosion on your really expensive equipment, and let's not forget the huge ESG impact. Having to deal with hazardous chemical discharge totally complicates your regulatory reporting and directly harms your plant's sustainability goals. So we really need a paradigm shift here. The old way relies heavily on reactive chemical cleaning, which basically means shutting down production, handling hazardous chemicals, driving up your recurring operational expenses, and ultimately shortening the lifespan of your shell and tube heat exchangers. But the modern, sustainable approach? That's all about preventative physical conditioning. We're talking about stopping the scale before it even forms, keeping your production online, and protecting the environment all at the same time.
Which brings us to Section 3, the AE Flux innovation.
Now, the mastermind behind this preventative approach is a company called Advanced Engineers. And look, they aren't just equipment vendors. They are industry-leading experts in energy efficiency and automation. With over 15 years of hands-on experience optimizing utilities for major industries, they're actively helping plants transition away from that costly reactive maintenance and moving them towards smart preventative engineering. And their flagship solution for this specific scaling problem is literally transforming how we handle industrial water.
Enter the AE Flux device. It's an inline physical water conditioner, and what makes it truly revolutionary is actually what it doesn't do. Get this, it requires absolutely no electrical power to operate. It has 0 moving parts, and it uses absolutely 0 chemicals. None. You simply install it inline, and it gives you a maintenance-free, permanent solution that conditions the water before it ever even has a chance to scale up your heat exchangers. It's a real game changer.
So how does it pull this off? That's Section 4, changing mineral morphology.
Let's move to this process and see how it builds, because you're probably wondering how it works without adding any chemicals. It actually happens in 4 crucial steps. First up is pipe charging. The AE Flux unit couples a highly controlled electromagnetic field right through the pipe and into the flowing water. Second is flux interaction. This field creates Lorentz forces, which is just a fancy way of saying it alters how ions collide and move around within the water column. Third, we get the morphology shift. This interaction modifies the electrostatic conditions, literally forcing the calcium carbonate to change the way it crystallizes. And fourth is deposit repulsion. Because of this structural change, the minerals completely lose their ability to stick to the metal surfaces of your shell and tube exchangers.
Okay, this right here is the real aha moment. Normally, calcium carbonate forms as calcite. Those are sharp, hard, highly adhering crystals. That's what builds up that nasty insulating layer. But after passing through the AE flux field, the mineral is forced to precipitate as aragonite, which consists of smooth, soft, suspended microcrystals. And the crazy part? We haven't changed the water's actual chemistry at all. Nothing was added, nothing was removed. We just changed the physical shape of the mineral, which means that soft aragonite simply flushes harmlessly right through the system.
Which leads us perfectly into Section 5, Progressive Descaling without Shutdowns.
Now, you might be thinking, okay, that's great for stopping new scale, but what about the fixed scale that's already trapped inside my shell and tube heat exchangers right now? Well, the answer is progressive descaling. Because the AE flux-conditioned water is no longer dropping new scale, it actually becomes capable of absorbing the existing deposits. So, over a period of a few weeks, the legacy scale inside your system is gradually dissolved and safely removed, all during normal flow. You are literally cleaning your heat exchangers while your plant continues to run at full capacity. No shutdowns, no harsh acid washes, just a smooth, steady return to peak efficiency.
And when we zoom out, the macro-level impact of this is just profound. When you install AE Flux, you aren't just protecting a single shell and tube exchanger, you are triggering a comprehensive plant-wide transformation. This localized morphological shift creates cascading benefits across your entire cooling tower loops, your HVAC chillers, and kilometers of industrial pipelines. By addressing the root cause right there in the water column, you're effectively protecting the entire anatomy of your plant's thermal infrastructure.
So the crucial point here is that the operational shift is just night and day. Just look at this breakdown. Before AE Flux, you're stuck in this high OpEx nightmare. Frequent acid cleanings, costly production shutdowns, dropping U values, and the massive headache of hazardous chemical disposal. But after AE Flux, maintenance interventions are massively extended or just outright eliminated. Production remains completely uninterrupted. You recover roughly 95% of your original design U values, and your ESG impact improves drastically since you have zero chemical discharge.
And here is where all this brilliant engineering translates directly to your bottom line. 22 days. In a heavily documented case study provided by advanced engineers for a high-demand heat exchanger system, the energy savings from recovered steam and reduced pump electricity were so massive that the entire capital investment of the AE Flux device paid for itself in just 22 days. I mean, that's incredibly fast. And after that, all those savings drop straight to the plant's profit margin every single month.
This really leads us to a powerful philosophy, because every unit of energy saved is energy generated. By stopping scale, you aren't just saving money. You are drastically lowering your fuel consumption and shrinking your carbon footprint. Honestly, avoiding scale is genuinely one of the most effective, immediate ways for your plant to hit its sustainability and ESG targets. You are literally protecting the planet while boosting your profits. It's a total win-win.
Which leaves us with this final, pretty provocative question to consider. What is the silent killer inside your heat exchangers actually costing you today in wasted energy, lost production, and chemical maintenance? Are you ready to stop accepting scale as a normal cost of doing business and finally upgrade to chemical-free efficiency? If you are, I highly recommend reaching out to the experts at Advanced Engineers to evaluate how AE Flux can transform your specific plant. Thank you so much for joining me on this explainer, and hey, here's to a more efficient, scale-free future.